Duncan Watts is one of the world experts in analyzing social networks and learning about what's going on inside of them. He has been a professor at Columbia University and also a network scientist at Yahoo Research. And most recently, he's moved to Microsoft Research in New York City. We weren't able to get video footage of our conversation together, but I think you'll find it interesting anyway. What are some of the factors that have contributed to the explosion of interest in social network analysis?
So what's changed recently, and I mean really just in the last few years, is that with web data, it's finally possible, at least in some instances, to see precisely how information spreads from one individual to another. I wrote this book called 6 Degrees, almost 10 years ago now. It was published in 2003. One of the messages that I tried to convey in that book was that what we now call network science is both in theory and also in practice a multidisciplinary endeavor. The origins of what we think of as network science now really began in the social sciences. There was an enormous influx of physicists into this field in the late 1990s. And then as the web continued to evolve, and you see the computer scientists get more and more involved because they're probably the best equipped to handle very large data sets. Many people are interested in this question of how did you sort of replicate the success of Facebook? And the best of our scientific understanding is that you sort of can't really. There's a lot of very sort of specific algorithms that network analysts use. Everything from very simple breadth-first search algorithms to community detection algorithms. Often where the state-of-the-art challenges lie, at least in the recent years, has been implementation, particularly scaling issues. Pretty much everything these days is done using MapReduce, right? So I think that if you want to work with very large-scale network data, then some familiarity with the MapReduce framework and whichever implementation, I guess Hadoop is the most common one these days, is going to be extremely valuable. And there's been some interesting theoretical work showing how algorithms like breadth-first search can be converted into a MapReduce, a parallel framework, and that's actually generated a great deal of recent progress.
Can you tell us a little bit about the idea of community detection?
You want to assign everybody in the network to a community such that the communities you choose have the property that most of the links are within the communities, not across the communities. One of the methods that was developed by my colleague Jake Hoffman, now at Microsoft, but when he was at Columbia, is called stochastic block modeling, where you are starting with a network, and you are assigning. You start with some sort of prior assumption about how many communities there are in the network, and then you sort of make a guess about who goes into which community, and then you measure the relative densities of internal versus external links. And then you shuffle back and forth, making various random changes to try to optimize the allocation of people to communities in order to get this sort of maximization of modularity.